Welcome, everyone. Thanks for attending. My name is Fabio Viggiani. I work for TrueSec, and what I do there is working as a penetration tester. So what we do as penetration tester is basically try to compromise our customers' systems, and we try to do it before the bad guys do, so we can go back to the customer and say that's how we got in, and that's what you were exposing, and why it was vulnerable, and how we escalated, and so on. And well, what we try to do is then make the customer understand what the mindset should be when they implement security solutions for their organizations. And I think this last part is what actually makes a difference. So we're going to talk a little bit about that in this session, but we're going to focus on web applications. And well, there are a few reasons why I want to focus on that. Well, for one, I just think it's fun to hack websites. It's like you have someone building like a nice web application with cool features and fancy security measures, and then you just go and smash it. A bit like a kid, I'm sorry, can't help it. No, but seriously, web applications are the biggest exposure that organizations have today. If you look at how things work today, that's just how it is. Every organization exposes some kind of web application in one way or another, and if you look at what happens when organizations get hacked, in many cases, it all started thanks to a vulnerable web application that was exposed to the internet. Someone got in, and they use it as an entry point to escalate and compromise the whole thing. And I think it's interesting to try to understand how these attacks take place, so what kind of vulnerabilities the attackers actually exploit. And how many of you know what OWASP is? Okay, good, almost everyone. So OWASP is the Open Web Application Security Project. It's a non-profit organization that focuses on web security. They do a lot of things, and one of those is maintaining a database of web hacking incidents. Now, of course, this is just a tiny subset of what actually takes place in the real world. This is just what's being recorded and actually entered in the database, so there's much more to it. But I think it gives a good indication of what the trend is and how things happen today. So this column, the attack method, I think is particularly interesting. This is basically the vulnerability that attackers exploited to get in. So we can see we have cross-site scripting. If my mousepad decides to respond, I can scroll down. We can see brute forcing. Well, most of them are unknown. Then we have some denial of service. Then we have some SQL injection, some SQL injection, some SQL injection, some SQL injection, some more SQL injection. And if you scroll down, you'll find a bunch of cross-site scripting. So isn't this weird? I mean, we're in 2015. Are hackers still using SQL injections to compromise organizations? I mean, I think that's kind of strange. SQL injections have been around pretty much since relational databases were invented, right? So there are well-known countermeasures, there are accepted solutions to solve these problems, but we still find them almost every day when we do penetration testing for real customers. It's not something I just come up with in my demos. It's reality. So what we're going to do in this session, we're going to try to see a couple of examples of how it can go bad sometimes, even if you think you have security measures in place. So what we're going to do is we're going to follow an attacker during an attack. And we're going to target a certain organization with the ultimate goal of extracting internal information from a database. And you should keep in mind that the examples I have in my demos and examples are not something I just came up with. They're actually reconstructions of vulnerabilities that we found for real when we do penetration testing for our customers. So just keep it in mind. So let's start with the demos. I'm going to use a couple of virtual machines. This one is going to be my attacker machine. I'm going to attack from here. And this is the main website of the organization I'm going to target. The address is ext.cyberlights.com. So let's try to draw something here with my fancy thing that I'm not really good at, so it's gonna suck. But anyway, I have my external. Yeah, I told you. My external application that I can target from the internet, right? So I start from there. So what usually happens is when we hack into organizations, we don't go from the main front door. That's usually fairly secure. And there are often other ways around the front door, easier to exploit, that will still get you a foot in. So let's assume now that this main application is secure. We can make that assumption. You shouldn't, but let's make it now. This site is fairly simple. You have a home page, you have a contact page with some contact information and a documents section, which apparently you need to be logged in to access, and well, the login function itself. Again, assume this is secure. So what you want to do in your first, when you first start attacking a certain target, you want to gather as much information as possible about the target. I could talk about information gathering for a day. There is a lot to it. But the idea is you just want to try to find the weakest link, find the weakest entry point, as well as all information you can get, which you might reuse in other parts of your attack. So since I only have 40 minutes, what I'm going to do here is look at the page source of a certain page. And something that sometimes might not even seem so interesting, we have an email address of someone that was somehow involved in this organization. Just we keep it in the back of our head. We have an email address. We might use it. And what we can also observe is there is a external link to a forum site. If we browse to it, we have another site called forum.cyberlabs.com, which is still part of the same organization. So what we're doing is simply extending our possible attack surface. We now have two, if I find my pointer, we now have two internet-facing applications that we can reach. So what do? We start looking around in this application, and while we see we can't really do much if we're not logged in. So we just try to reach the login page. We can observe something a little more interesting now. I'm going to copy-paste here on your notepad so it's more readable for you guys. Is that good? All right, so this login page accepts a parameter called return URL and a value, of course. And that value in this case is the location of the homepage of that website. So this is something that is often overlooked, and we find it a lot. It's a problem called insecure redirections, which basically means that I can trigger a redirection to an external site from this vulnerable website. So the purpose of this function is take that parameter, and after a successful logon, you will redirect the user to that location. So if the page, if the website is vulnerable, you can write here something like an external site. And after logon, you will be redirected to, in this case, TrueSec.com. Now, the reason why that's often overlooked is that, well, I mean, what's really happening is you trick someone to specify a certain return URL parameter here, and then when they log in, they get redirected to an external location. How is that bad for my forum site? Why should I care? Well, there are a few reasons. We're going to see an example of how we can use that to construct this very simple phishing attack and steal credential from a victim. I have it pre-cooked because I don't have time, but otherwise it would be really, really simple to do. So this is what's going to happen. This is actually what our goal is going to be. I'm going to first draw it here. We want to, first of all, trick a victim over here to visit the forum site by specifying a certain return URL parameter that we decide. Now that parameter will point to a location, which is a web server on the internet controlled by the attacker, controlled by me. Now after log on, the victim will be redirected to my site. Let's start with this first part and see how it looks. So what I want to do as an attacker, I want to check my IP address first of all. Here. So I want to redirect the victim here. And I have a web server listening on this address with a page called login.html. Now, of course, in a real attack, that would be an actual domain name that maybe even looks similar to your target organization. Pardon? I'm going to show you right now, just as an example. If you remember, I have an email address of someone involved in the organization, right? So the simplest thing I can do is I send an email to the guy or girl or whoever. So that guy was John Fooled. So we're going to send an email, say help or whatever. I have a problem with this page on the forum site. And well, this page will actually be a URL to that location, including the return URL that I specify. Right? Hit OK. Now you can be as creative as you want. Send this to your victim. If I have internet connection, which I should. Or at least I thought. OK, you know what? I don't have much time, so I'm just going to simulate this. You guys are with me, right? Sending an email is not that interesting anyways. So I'm going to copy-paste this and say the victim will receive the email and click the link. So it will visit this location. Now that's the actual forum site. That's the real site. We're just providing a parameter that we decided as attackers. So what does John do? He's going to write username and password. And log in. Now, apparently, he entered something wrong. But actually, what happened is that we are redirected to my attacker machine. And what do I host? Well, apparently the same page. It is actually a clone of the original login page right here. Clone. So I just changed a couple of parameters, but it looks exactly the same. So if you don't pay too much attention to the URL, or if that looks legit for any reason, or if you don't see the URL at all, it's an embedded iframe, for example, or whatever, you might actually write your username and password again, because you just thought you entered incorrectly. Now, of course, this data is going to go to me. That's a request to my web server. I can do whatever I want with my web server. I can just take that and log it to a text file, which is exactly what I'm doing. And then I am redirecting John Fooled back to the original forum site. Right? And of course, I have a valid session because the credentials that John entered initially were correct. So if I go back to my web server, I now have a file called collected.txt. If you open it, you got the credentials of John Fooled. Simple example. There is much more evil things you can actually do with an insecure redirection. But the thing is, we just overlooked it because we thought it would not really involve us as, this organization. Well, an example of how it can actually affect you, or maybe not you directly, but your users. Then you have credentials to log into the application. So what we're going to do is use those credentials to log on to the forum site. Now we're in. And once again, we want to try to get as much information as possible about this new location that we found. For example, there are some posts. Apparently, this John Fool guy also posted something on the forum. He had a problem while he was trying to, add in a user to this site, to the external site, actually, to the main front-end website. And he got an exception. It's just pasting here the result of the exception, hoping that someone will help. Is that unlikely? Well, maybe it's unlikely to have a function called add user with username and password. This is just, I just made it explicit, but that's, you get this kind of things. You just go to a forum and you gather information. You actually get a lot of information. So now we know there is a function hosted by this web application called internal.cyberlabs.com with a function called add user, passing a username and password, and apparently, judging from John's post, this will add a user to the external application. So what kind of information do we have from our attacker's perspective? We know that John or another internal client will be located here, and there will be, of course, a separation between what's exposed to the internet and the internal application that John was mentioning in his post. Now, this application has a function called add user, and this somehow will add the user to this application. We don't know how things work. We have no insight, but we know, this is what we know. So this is what we can deduce at this point. Now, this is what actually happens in real attacks. You don't just have the knowledge. You build it yourself. So let's go further. So what do I want to do? Of course, I want to use that function, right? I want to use that function to add a user. But I can't, because I'm out here, alone in the cold, and I can't access the internal application. So what do? I want to target an internal client to make that call for me. Remember the initial database I showed? What's another very, very common vulnerability? Cross-site scripting. That's a client-side attack. Client-side attacks means, what cross-site scripting does is basically injecting arbitrary scripts or HTML content into a web page, and then waiting, in the case of a store cross-site scripting, for a victim to visit that page and execute the code that I injected in his or her browser. So what I want to do is inject a script or some content, let's say a script, into a page on the forum site. And then I want to wait for John to go and visit this page. And of course, the script I have here is going to be rendered by his browser and executed here. So if I make a call from that script to the add user function internal application, now that script will be run in the context of John's browser, which has access to the internal resource because that's where it's located, right? Now, luckily enough, I have a function to add a post, because now I'm logged in as John Fold. I can add posts. So I'm not gonna explain the details of how cross-site scripting works. It's pretty straightforward, and I assume most of you know. So let's test if XSS works. What do I want to do? Well, proof of concept, we're going to send the script that simply pops up a message alert, XSS. We're going to send it, but the application doesn't seem to be too happy about that. If any of you is familiar with .NET, you should recognize this. This is a feature that is built in the framework, in the .NET framework, which is called request validation. It implements some kind of input validation mechanism. So if you recognize a certain pattern, it will throw this exception and it will reject the request. And that pattern looks something like this. It's basically just a opening script tab and any other character. So if you follow this, sorry, if it finds this in the user data, it will throw the exception. It's actually not every character, but every character that matters in this context. There are actually also other patterns. But anyway, if there is something that looks like HTML tags, it will throw the exception. There is something interesting about how this works, because what happens is, at least in a default configuration of a .NET MVC application, when the application receives data, depending on the type of input that you have in your request, that request or that input will be handled by different handlers, and there will be different value providers involved in that process. So for example, if you have a parameter in the URL, there will be a certain value provider taking care of that. If you have a value in the body, like a post parameter, then it will be handled by a different value provider and so on. Now, it's interesting that the value provider itself is responsible for calling this feature. And well, guess what? Not all value providers do that. So if I know of a value provider that does not involve calling this feature, then I want to try to make my request look like that and have that value provider handling my request instead. For example, that is the case with JSON. So I'm going to use a local proxy here. This is just intercepting a request coming out from my browser, so I see it in its entirety, and I can edit it before sending it over to the server. So I just start my interceptor, and I send something. So when I hit save, this will be caught by my local proxy. This is the request I'm sending to the server. So what I can do is change the content type. Instead of the regular form post parameters, I can send a JSON request instead, which by default is accepted in a MVC application. And of course, I need to change the format of the data itself. No, that's not going to be a test. I want to actually have the script in there. Tell me if I misspell something, please. Script alert. Close that. And close. That looks like JSON. Now we forward this, release the interceptor, and we can see that our script was actually accepted and stored, and now when we reload the page, we execute the script. So now we know we can do this. We know we can place a script right here that will make the call to the add user function, and when John visits that page from an internal machine, his browser will make the request, will be granted access to the internal application just because it's located internally, and boom, we add the user. So let's do that. I actually don't even need a script. I can do this with plain, simple HTML. It's just a GET request I need to do. I made it simple because I have the parameters in the URL, but you can do it with a post. It doesn't really matter. Let's see. This is what I want to inject. Let's make it bigger. I want to inject a simple image tag with a source that is the request that I want John to do. So when John's browser interprets this, we'll try to look for an image located in that location, and it will make a request to that location. Now, the fact that the image doesn't exist doesn't really matter because we're going to hide it like this. So let's do this again. I want to intercept again. Go back, change JSON. I was actually doing this demo yesterday on stage, and I thought I'm going to copy-paste this. But of course, I forgot to do it. Paste that. Now, I want to escape the double quotes. Close. And close. Forward. Now, of course, I still have the other script. That's the other post entry. And down here, I have a new post with the hidden image. Cool. So let's see. Now, I'm back to the main site. I want to try to, oh yeah, by the way, what I tried to, you probably saw it without me telling it, I'm trying to add a user with username hacker and password hacker. So I want to go to the main site and try to log on with hacker. Of course, it doesn't work. So what I need to do is just sit down, relax, and wait until John visits that page. Now, John will eventually do that. We'll reload this page, execute everything I injected on that page, including the image, which will trigger the request that I want. Now I go back, I try again. Boom, I'm in. So that's what happened. It's, John is executing my script over here, making the request for me, adding the user to the external application, which lost its boundaries, and then I can log in. I'm gonna take it one step further, and then we're gonna wrap it up. So what do we know so far? We are over here. There are two different applications that are facing the internet. We have the external. We have the forum. That is a separation to the internal network. We have internal clients connecting to an internal application, adding users and stuff. Now, this external application will have a database connected to it, most likely. Remember all those SQL injections we saw at the beginning? Well, you probably know that you should use prepare statements, or you can call it parameterized queries when you talk to a database. That's what you should do. And that's what these guys did here when they programmed this application, because they're internet-facing applications, so they're both secure against SQL injections. So what you want to do in a SQL injection attack is you want to tweak your data so that you break out of the SQL statement itself and you affect what the SQL engine is actually executing. So normally you would want to enter like a single quote or something that breaks the query. So you want some character that has a special meaning in the SQL syntax to modify the syntax itself. If you use prepare statements, those special characters are going to be escaped at the time of execution. So basically, you're going to tell the database engine, this is user data, and you pre-cook that statement. You prepare that statement. And then you enter the parameter, but at that point, the SQL engine already knows that that's just data. So whatever is to be escaped is going to be escaped. Now, we also have probably another database connected to the internal application. And remember, when we added the user, we called the function over here, and the user was added over here. So what we can observe from the external is that something might be going on between these two guys over here. So we might have something like a synchronization or whatever component in that system that takes some data from here, puts it here, and vice versa, or we don't really know, but something's going on. So what happens when you use prepare statements is, as I mentioned already, you have your data coming from the attacker. This might contain whatever, a single quote. Now, you're using prepare statements over here, so when you execute the statement, clean this up a bit. When you execute the statement, that single quote is going to be escaped, probably with another single quote. I'm going to show you this. On the external side, I have a profile page. Now that I'm logged on as hacker, I can update my description. So that's probably going to be stored in this database over here, right? So let's say I want to try to update my description and concatenate into that the version of the SQL server. And I try to update my description to that. Well, I can see that what I see is what I literally entered. So obviously, what's being stored over here is again my original query. So if I add a single quote, it's going to be a single quote. It's going to be escaped at the time of execution over here. But what's being stored is exactly the data that I enter at the beginning over here. Right? So what does it mean? It means that if there is any other component in my entire system that is reusing that data, it can't just assume that that data is fine because it's coming from an external secure web application, because that's user data still. So we have to take the same precautions. And that might not be a web application with a focus on security, because it's an internal component doing things between databases. We don't really care about what's coming from the internet. That's somebody else's job. And they actually did their job right, because they were using prepare statements on the DMZ. So, as you can imagine, we have a problem here, because that component is not going to be doing that securely. So that input is going to be reused insecurely to conduct a query that affects the internal database. So if I have an injection attempt over here and escaped here, still stored in the database as I enter it initially, this component is going to take it, execute a statement using that data, and I can have the injection over here. That's what we call a second-order SQL injection. When you store your injection somewhere first, and then some other component takes that, reuse it, inject it somewhere else. And it might be much more complex than that. This is, you might have backend web services even connected to other organizations, and you should never assume that the data is safe because someone else treated it. Assumptions make us weak. So I'm just going to show you how this works. I have a few more minutes. Now, of course, you need some pretty lucky guessing here, but it's just to show the concept. So say, not even guessing, just a lot of attempts. So what do I want to do if I have an injection in the internal database? Well, as I said at the beginning, I want to extract information from the database. I want to compromise that server. I want to execute code on that server. This is a stored procedure that you can use to enable common execution on the server. Of course, this requires to be the highest privileged account on that SQL server on a database level. Do you think that's unlikely? That's not the DMZ operating anymore. It's this internal component here. We don't even know what it is. It's something internal. Might even be a script, not even an application. So I think it is likely that it's running with high privs. So I want to update my description to this, to enable command execution. Now, assuming that no one will go and read my description, I can go further. And get, for example, a list of databases. Now, don't bother about the details. Basically, what I'm doing is I'm running PowerShell on that server, invoking a web request, which will make a GET request to, again, my web server, where I have another controller listening called exfiltrate. We will just take some data, output it to a text file, and we have it. And I am concatenating that data with the result of an arbitrary statement. In this case, I want to enumerate all the names of the databases in that instance. So I do a select DB name 0, and then 1, and then 2. I just keep enumerating all the databases. So just to see that this works, I'll send it. Well, actually, even before that, I check my web root on my server. I still have the collected. That's going to be a different file. I update this, and then I wait until that component is actually used. It's going to be a partial synchronization running periodically, a script, whatever, a scheduled task. We don't know what that is. But every time it runs, it's going to run my injection and send me data. So every time it's synchronized, it's going to send me the name of the first database. I can proceed doing that for all databases. And of course, I can go further. And okay, don't have much time left. Just going to skip through this. You can get all the user-defined tables. You can get all the columns and whatever. And of course, we want to get the users table with username and password, right? Can't be a nice hacking demo without having some passwords. Now we just wait for our file to be updated. And there we have it. So I know there are a lot of concepts involved. Don't bother about the details. I'm going to wrap it up and really try to understand what are the main things that have been wrong from the perspective of who built that system. Because things seem pretty fine from external, right? We had 2 fairly good web applications. We had one problem with the return URL parameter. We use it to do a phishing attack, and then we escalate. So that return URL parameter, we kind of overlooked that problem. We just trusted the user input. Well, the thing is, it doesn't really matter if you think it matters or not. I'm sorry, but we're people, we make mistakes, right? So the best we can do is structure our application so that we don't even have to think about doing these kind of things. If you were here in the session before, my colleague Andreas explained some possible solutions to structure your application to do these things by default every time, talking about input validation. Another best practice we didn't really follow is that we were trying to prevent cross-scripting by validating the input. That's what the .NET request validation feature does. And well, if you go and read about cross-scripting, you know that you should not rely on input validation if you're trying to prevent cross-scripting. What really matters is when you send the data to your users, you're going to HTML encode it so that you tell their browser to not execute that. So even if I manage to inject, it doesn't matter. Of course, you should do input validation for an infinite number of other reasons. But for cross-scripting, you should really just care about encoding the output. Also, we did not really understand how that feature works. Again, if you go and read the documentation on Microsoft's site about the .NET request validation, they will tell you, hey, this is not something you should rely on when you try to prevent cross-scripting. This is something we have there because it's nice to have, some limitation of at least the most basic attacks. It can be an automated script just browsing the internet for potential vulnerabilities or whatever. This is just going to block it, right? But it's not something you should rely on. If you want to prevent cross-scripting, do output encoding. Again, best practices. So on a more general level, we had a problem of consistency in the environment. Remember, we had our 2 internet-facing applications, and they were fine. And then we had that small little component internally that messed everything up. So once again, you should try to structure your application to do these things by default. It doesn't matter if it's an internal small component or if it's the internet-facing main front door. You should have it as a practice, as procedures inside the organization, as a development team, to just structure it so that you don't have to think about it. Or if you do, then you just follow procedures. I know, I mean, you need to think. Of course, you're a developer, but some things, just do it because it's best practice. Just do it. Be consistent throughout everything. So structure your application. Every time you get an input, it's going to go through input validation. Every time you output something, it's going to go through HTML encoding. Every time you talk to a database, it's going to use prepared statements. If you structure your application to do these things by default, it's not up to you guys to remember to use it all the time. And I know the answer is not that exciting, but I'm sorry, that's reality. That's the real world. And I believe these are the main reasons why we have still a lot of these well-known problems. It's a matter of structure, really. Sorry, not that exciting, but I think this is important to understand. So that was pretty much it for me. I'm going to be on stage for another 10, 15 minutes or so feel free to approach me and ask me stuff. That's fine. So thank you very much for listening.